Okay, so first question, be quiet please. Okay. First one says solve using the graphing calculator. You have a choice. You can get everything to one, you can expand out, get everything to one side, collect like terms. And then if you do that, you're looking for the X-intercepts. If you, another way of doing it, is to graph the left side into y1, right side into y2, find the x values of the points of intersection. You could get everything to one side, just not expand and collect like terms, right? So if you wanted to, you go to, you could just leave it, x bracket x cubed plus 8x squared.
Wait, how did you do that?
Go back and insert. Okay. Plus x. So then what I would do is I just subtract 10x and subtract 3, or you could subtract the bracket 10x plus 3. Okay. Now, when I'm doing it this method and I'm looking for the x-intercepts, how I like to do it is graph y equals 0 and use intersect, as opposed to using the 0 feature, having to go left boundary, right boundary, and so on. So I tend to graph y2 equals 0. When you're using this method, you don't care about the y's. You don't have to change your window in terms of y's because you're looking for x-intercepts. Maybe you need to expand out your x's, but if you take a look at this, I see 4 x-intercepts from what I can tell. Take a look at your original. If you were to expand that out, what degree is it? Degree 4. So you know you're not missing any, right? If that was degree 5, then could be that there's another one, right? If you're just looking at it, now you could analyze what kind of intercepts and know, oh, maybe there isn't another one because it's got a tangent at one place or whatever. This I know I can see all of them. It says find them and express to the nearest hundredth. So because I've graphed y equals 0, I'm not going to use this 0 feature. I'm going to go right to intersect. So I'm just going to press 5. It usually goes to the y-intercept with a P. And so if I just enter from now, it's going to go to the closest x-intercept. So enter, enter, enter. It's going to go to the closest one. In order to get the other ones, you're going to have to cursor closer to them. So one of them is negative 0.31. So now there's 2 more. I'll probably move that over actually. I'm going to put them in order. So you could, if you want a cursor closer, you can. On my calculator, this one is a pain to cursor closer. I'm going to enter a value like negative 2. As long as I'm in trace, it will go to the point with the next value of negative 2. It's at negative 27. Okay, I can't even see it, but that's okay. I know that it's closer to that one. So now if I go second, trace, intersect, then enter, enter, enter. Oh, it was. Not quite sure why. So I should be closer to that one. Anyway, it gives me another one. 1.12, that's interesting. Okay, questions? There's a lot of talking. This shouldn't be new. So, sorry, I'm going to get out of that. I'm going to be in trace mode. I'm going to go closer again, so maybe -1. Okay, there I'm close to that one. So second, trace intersect. Enter, enter, enter. -1.10. And then over here, -1, 2, 3, 4, 5, 6, 7, 8. So trace mode, -8 gets me closer. It's way up high, 141, so I am going to cursor closer. It's got big jumps there, right? Just because it's so steep. So now second trace intersect. Okay, -7.71. That's graphically. If it's in a multiple choice generic response, you don't need to show work. You can do it that way, right? If you want to check your algebraic work, you do it that way. Okay? So it's just another method. Next one, we do have to solve algebraically. This is sometimes what I'll see. Don't copy it down. What's wrong? Yeah, I'm missing something, right? So I noticed that there was not x minus 1, sorry. That's what I might see students do. Divide both sides by x minus 3. Okay. Remember, we talked about this back in math, 10 IB, 20 IB. Don't divide by x or any expression with x in it. Basically, unless there's no other way for you to do it. Okay. What you've done there is eliminated a solution. And in the same sense, even if you did find it, now x can't be 3. But 3 is a solution. So please do not divide both sides by x or some translation of x or factor of x or whatever. Okay? So a lot of students would do this and say 4x squared equals 1, divide by 4, square root, plus or minus, and be done. They are missing a solution, so you won't get full marks for this. So what should you do? A couple of different things. If you notice these are the same, put brackets around it, you could bring that bracket to the left, and you won't have to use synthetic division. Why? Because this is a common factor. Remember back to your math 10 factoring. You can factor out that bracket. This is the difference of squares. And your solutions are 3 minus 1/2 plus 1/2. So plus or minus 1/2. Okay. So doing it that previous method, where you divided by x minus 3, I got 2 of the roots, but I did not get the third one. Okay, so you're not going to get full solutions. That's how you can do it without even needing to use synthetic division. if you notice that bringing everything to one side, always you want one side equal to 0. If you did that, kept the brackets on it, you've got a common factor. If you expanded it out, then you would need to look for your potential zeros, graph it, find one that works, show your synthetic division, show it in that factored form, and then factor the trinomial again. Obviously, there's going to be a trinomial. Okay. So maybe you want to, on your own time, practice that method. Okay, we're going to do that method for the next one. Next one, I can't factor by grouping and be able to factor it, so I have to use the factor theorem to help me. In this case, these are all integers, and the coefficient here is 1. So really, I only need to look at this. So my potential zeros, or in this case, actually, it's an equation, so they are roots, or solutions, will be plus or minus 1 and 10, and 2 and 5. We can pair them up like that, we can put them in order. I don't care if they're in order or not.
We do like plus minus and then bracket.
Or plus minus out front and then all of them in brackets. Now, looking at this, look at the coefficients. 2 of them have 1s. One is a 10, one has a minus negative 11. Maybe if you substitute 1 in or negative 1 in, might work. Maybe you don't even need your calculator. So if I put 1 in there, I get 2, negative 9 plus 10 is 1. Nope. If I put negative 1 in there, I get negative 1 plus 1 is 0. I get 11. Oh, no, it doesn't. Sorry, I was thinking that maybe it would. Sorry. Sometimes when they're closed like that, it might. So, x cubed plus x squared. Okay, noise level, please. Just think in your head, please. Okay? Or ask me questions so that people have peace to think themselves. Okay, so in this case, let's try 1. Right? That doesn't look exact. That doesn't look exact. So what that tells me, oh, nope, that isn't 1. Is it 2 exactly? Okay. So what this tells me is that's not an integer, that's not an integer, but this coefficient is 1, so we haven't even got fractions as possibilities in there. So what that tells me is that these are going to be irrationals. They're going to be a quadratic that we need to most easily use the quadratic formula. You can complete the square, but I wouldn't bother doing that. Okay, so we're going to go with this. So here, this is an equation, so I'm not going to call it P of x. So I'm going to say when x is 2, or I'm going to say just x equals 2 solves the equation. Set up your synthetic or long division, up to you. Okay. Bring down the 1. Negative 2 times 1 is negative 2. 1 minus negative 2 is 3. Negative 6. Subtracting a negative is adding. Okay, if you did not choose the correct number, you won't get 0. So go back to your graph. If you don't get 0, or check your synthetic division. So now I'm going to show it in factored form as the equation, not just the expression. Okay, so you need the equal 0. So here, that's going to be x squared plus 3x minus 5. And you can see, you can't factor that. So that's why you need to solve that part using the quadratic formula. Okay. You should remember it, you will be given it, but you really should remember the quadratic formula. So this part here, okay, so you want to check your calculator. If you find that x-intercept or that one, it'll give you the decimal form, right? It cannot convert from the decimal back to the irrational form. So how can we check? You could do intersect again. Cursor closer. Come on. Okay, enter. Okay, so there it is. If you quit out of the graphing screen, so second mode, and then copy X out and enter, it will copy the X value that your cursor was last on. Okay, so then I want to check. That was the rightmost one. I want to check to see if this is the same. If you have a fraction capability, if you have a newer calculator, you can go alpha y equals the fraction, first one, and do -3. Sorry. I'll do the plus, the positive one, square root of 29, cursor down, 2, enter. Okay, make sure it's the same. Or on your graph, you could enter that as your x equals and make sure y is 0. Okay, so there again, another way to check. Questions about that in your calculator? Okay.
How do you get the? Sorry, how did you get the root? The fraction.
If you have a newer root, yeah, you have a calculator. Fast way, I think there's other ways, but so alpha and y equals, and it's the first one.
Oh, okay. What are the other ones?
I don't know. Never used it. Okay, so make sure, don't just leave it like this, because you have a solution of x equals 2. Yeah, you've set it up there, but you have to summarize. So I go 2. You can keep these together. If you want, you can show them separately. Sometimes solution sets, we actually put those squiggly brackets around them. Okay? To say that's the solution set. I'm not too picky about the squiggly brackets, but some teachers are. So.
Because technically, if you write it like that, if you diagonalize.
Without the brackets?
Well, no, because you include the x in the brackets, that changes the answer.
Yeah, you'll see it that way. You'll see it separately too. I'm not too involved on that. Okay, so that's a review for you guys from last year. Next thing is actually new. All right. It's not part of 30-1 regular. It is IB, but it's not really harder. Actually, makes things easier. But we will give you these formulas, okay? And they will be in your data booklet when you go to write your IB exams, okay? But it is kind of nice if you can memorize them. Just in case, because they did change the data booklet, so we do have to check before every exam to make sure if they're not there. So take a look. Okay, we not talk. So this is good when you have your polynomial function in expanded form. So no brackets, right? Like terms collected, descending order of degree. So we're going to call this coefficient, the leading coefficient, A sub n, and the n matches the degree of that highest degree term, right? The exponent. And then you go down all the way to the constant term. You might not have all terms. Maybe you don't have an A naught, it's 0 then. Maybe you don't have, maybe it's x to the 5th, and then it goes right to x cubed. That means x to the 4th has an A value of 0, right? So just fill it in like you do for synthetic division. Summation notation, so you talked about that in Math 20. So notice how starting at r equals 0, so A0 times x to the 0. Well, x to the 0 is 1, whole thing, so that's A0 there. Then r equals 1, so A sub 1, x to the 1. So that would be that term, and so on, okay? So here's an example. That polynomial equation has the following A values. So the coefficient here, the leading coefficient is 3 of the degree 4 term, so we would call that A sub 4. Then cubed term, coefficient of -2, take the sign in front. There is no squared term, so A2 is 0. There's the next term, it's just x, so A1 is 1, and the constant term is 4, okay? So there's some interesting properties of the roots of polynomial equations in expanded form. If you take the roots and add them all together, find the sum of all of them, you will find that that value is equal to the -1 times this, or negative of a to the a sub n minus 1. So the next term, okay, the second highest degree term, coefficient divided by the leading coefficient, okay? Product of the roots, if you take the product of all the roots, it's equal to -1 in brackets to the exponent n, whatever the degree is, times by the constant term divided by the leading coefficient, okay? So this will, we can use this to find some missing coefficients of polynomial expressions. And that's what we're going to do. Okay? So again, you don't have to memorize it, but it might be helpful to you. Okay, so we're going to verify these. So there's that polynomial function, the first one we did. There are the roots, we found those. So add them together, find the sum. Well, these are opposite in sign, so pretty easy to add those together. Okay. What's the product? So you're multiplying them all, it's going to be -3/4. Now, we didn't end up, the method that I used, we didn't expand and get the expanded form of it, so we'll do that now. So the left side is 4x cubed minus 12x squared. Bringing everything to the left. Look like that. And let's verify. So negative, the coefficient of the second highest degree term, so that would be negative 12 over the leading coefficient. 12 divided by 4 is 3. Okay, that matches. We have the sum of the roots 3. That formula is 3. Product, so let's get this is going to be, so negative 1, it was degree 3. The constant term was 3. Leading coefficient was 4. Well, negative 1 cubed is negative 1, so that's going to be negative 3 over 4. Not your relief, okay? So if, let's say, I didn't give you the formulas, I just gave you this question to do. And then, actually, we're going to do another question. Another polynomial, the second one again, and you found that those match up. What kind of reasoning would we have used to be able to state that that is the product and that is the sum? Back to math 20, what type of reasoning is that when you're finding examples that show you something is true? Inductive reasoning, okay? So, math is all no, we're not doing it. There probably is. You could search if you want. Okay? Okay, so next one, given the roots, some of them you might think, oh, that's got radicals and everything, but remember, these are opposite in sign. So if we're adding these together, those terms actually go away. So we have the same denominator. So then we're going to have two of these. So we're going to have really negative 3 over 2 plus negative 3 over 2 plus 2. Please don't use a calculator to calculate. You have to know how to do that. So negative 3 over 2 plus negative 3 over 2 is negative 6 over 2, which is negative 3, plus 2 is negative 1. Product, well, I would group these together. Don't do this times this. These are conjugates, these numerators, right? So negative 3 minus root 29 times over 2. Negative 3 plus root 29 over 2. Then times 2. Now those are conjugates. So remember, first terms together minus last terms together. So that's going to be positive 9 minus root 29 times root 29 is 29. 2 times 2 is 4 times 2. So 9 minus 29 is negative 20 over 4 is negative 5. 2 is negative 1. Okay, so do they match up with the property? So negative an minus 1 is 1. An is 1, so negative 1. This was degree 3. Constant term is 10. Leading coefficient is 1. So that's going to be negative 1 times 10 is negative 10, divided by 1 is negative 10.
Wait, Miss McKay, I used n as 2 for the product, the letter D, and I got a positive 10.
Why would you use 2? N is 3, degree 3.
What do you have to use?
You have to use whatever degree it is of the polynomial. N is the degree of the polynomial.
Oh.
Okay, so in question 5, it gives you 2 roots. It asks you for the third root. I don't want you graphing it to try to find it. Okay, I want you to use these properties. Yes, on your 30-1 exam, you're allowed graphing calculators. This particular property is not part of 30-1. It's part of IB. IB has, you'll have either 2 exams or 3 exams, depending if you're doing SL or HL. One of those exams will be no calculator. Okay? So, if I were making up your exams, I'd say no calculator. Okay, so if you're doing the sum, remember the sum is the opposite sign of negative 11 over 6. So that's going to be 4, so that's going to be 1/2. Okay, so I use the sum. If you use, I'll just do it over here. If you use the I'll do it just quickly down here. If you use the product, you would have 2 times negative 3 over 2 times x equals negative 1 cubed times 24 over 6. So that's negative 4. This would be negative 3x. So x is 4/3. So you could use either method. Well, you have to show the repeating symbol. No rounding. But most times we'll say, if you say exact values, you really mean as a fraction. So try to use fractions as much as possible. example of a question that we've done before, right? We may have been given the roots, not know what A and B, some of the coefficients are, so we can substitute them in, right? And they should equal 0. So we would then have equations in terms of A and B. Okay, so we know how to do this, but in this particular example, when you're substituting radicals in, and you're cubing it or squaring, that's going to be messy. So that's where knowing these properties really can make it easier, right? Because now, okay, questions? Okay, so here we'll use the sum property, and again, if we're doing this, so we're finding the sum. These are opposite in sign, right? So it's going to be 2 plus 2 plus 3 over 2. So 4 plus 3 over 2 is going to be 8 plus, that's 11 over 2. Okay, so then that means 11 over 2 is equal to negative B over A. Can't solve that yet, right? We don't have enough information. Product, well, we've got conjugates, right? So put those together. Multiplying the conjugates together will give you 4 minus 5. Okay. So rearrange the roots if you need to. So that's going to be negative 1 times 3 over 2, which is negative 3 over 2. So negative 3 over 2 equals negative 1 cubed times 3 over A. So notice how here we just have one of the variables. So you can solve for A right away. So that's going to be negative 3 over A. So that's pretty straightforward. A has to be equal to 2. There's a funny looking 2 that doesn't make sense. So now substitute A equals 2 into that equation. So B would be negative 11. Okay, and in this case, I'm just going to rewrite them together. A equals 2, B equals negative 11. Make it obvious. Okay, so that kind of finishes our work with sum and products of roots. And then next question, we're looking at an inequality. Solve that. And the graph is given to you there. Okay? So the graph of y equals f of x is given, y equals g of x is given. It says state the solution to f of x greater than g of x. So there's likely going to be more than one answer. It would be an interval of answers. Okay? So take a look closely. I would kind of shade in, or not shade in, but circle the parts where this is true. Okay? So y equals f of x is this graph here. It's the parabola. And g of x looks like a cubic. Okay? Looks like there's 3 intersection points. Okay? And so, you want to think about for any x value, when is the y value on f higher up than the g value? Right? So here on y equals f of x, at this point here, those values are exactly the same. Okay? So we're not going to include that. Here, for x equals, say, negative 3.5, this y value for f is larger than this one for g. So that's true there. So this here, and so that's really, in terms of your x's, you could actually graph it on the x-axis, just to keep recording it for yourself. And you look at, say, when x is negative 1 here. This y value is g. It's bigger than f. Well, we want f to be bigger than g. So it's not going to be any of these values here. Okay, until you get to here. Then they're equal. And now the quadratic is higher up for any of these x values than the g values. So now it's going to include all of this. So that's really here. Okay, another intersection point. And then you have to, it's hard to tell what's happening there, but think about it. This quadratic is going up and to the right slower than this one. So now your g is going to be higher than your f. So we don't want any of that anyway. Okay, so that means x has to be less than negative 3, comma, x is between 1 and 4. Okay? That's your solution. You can put it into the brackets. Yep.
Can you have the or sign where the comma is?
Yep. You can use or. You can use union. Typically, we use the union symbol when we use the interval notation. So if you have, this would be more common. Okay. You don't have to have x element of the set of reals. In domain and range, you do. Okay? It doesn't hurt. You can have it. But you don't have to have the x, vertical line, etc. It's kind of like this. It's understood to be real numbers, but we never put real in interval notation. Can't you use it to yeah, imaginary error.
But since it's a graph, there's no.
Oh, sorry, imaginary numbers. I think irrational. Irrational is no. Imaginaries are not.
Not that. Can you express it easier? Like with the normal? Or would it be forward of picture?
Yeah. I'm sure about this one.
Yeah.
Okay. Let's see, folks. Okay, use your graphing calculator for the next one. Notice what it's saying there. So really, this is kind of like saying, this is your f of x, and your g of x is 0. It's a horizontal line. So you're really looking for all the values of x where the graph is below or on the x-axis, right? Less than or equal to. Okay, so if you look at that, you don't see any place there it's crossing the x-axis. Although I thought it was supposed to be. Yeah, so that you need to go to the window, but I thought I didn't have to change the window on this one. Oh, it's minus. That's what. That would have no sense. So the picture that I had there before, okay, I knew that that yes, you can change the window, but it's degree 4, so the arms were going up, okay, positive leading coefficient. So that means that likely there wasn't any more to it, even if I did expand it. The solution to that one would be no solutions. It never was below the x-axis. What happened was when I was double clicking or whatever, I did a plus instead of a minus. So now, stupid calculator.
There.
So now there are some because I thought there should be. And you can use your calculator again. I grabbed y equals 0 just because I like that method better to get the x-intercepts rather than using second trace 0 feature. But it's totally up to you. What you're looking for is all the x values in this part of the graph. You don't have to change your window. Here, all the x values between there. So really, you do need to get all of those x-intercepts, okay, because they're included in all of your solutions. So, I'm going to go to intercept. So it goes to the y-intercept usually. I'm going to enter. Okay, so there's one of them. That's the beginning of this interval. So I'm going to put that. And then it's got an equal sign, so I include it. So now I'm going to go cursor closer to the rightmost, then do intersect. Or a comma. Fast would be 1, 2, 3. Okay, last one is algebraically. Okay? So, algebraically, you're going to get everything to one side. That one, if you get everything to one side, I still don't think you can factor right away. You have to use your theorems. And in that case, you need to use the rational root theorem. Okay? Or you might need to. Still might be that it ends up being one of them being that use an integer, right? But you don't always know that, right? Okay, so looking at that, a little bit hard to see. Maybe you want to look a little closer, maybe go -3 to +3. Those x values are not very big. Okay, looks like none of them are integers, right? So this one looks like -1/2 to me. Yeah, you can do intersect, but if you think you know what it is, sometimes it's faster. So it looks like trace -1/2. If I get y equals 0, I know that it works, and I do. So x equals -1/2. Therefore, that factor would be 2x plus 3. Oh, sorry, 2x plus 1 will be a factor. In terms of synthetic, got to divide by 2. back to it again, if you can.
Thank you.
Okay, notice here, I solved the corresponding equation. Okay? This has a multiplicity of 2 at 1/3. And so I'm really supposed to solve that inequality. Okay, so therefore, I'm really solving this. Okay, and think about what that looks like. You graphed it. If I do a sketch here, then -1/2, 1/3. Okay, and positive leading coefficient. So going up here, multiplicity of 2 means it's going to be U-shaped, and then go through. So if I'm looking for where that's greater than 0, I cannot include these parts here. So it's this part here and this part here. Okay, so it would be x greater than -1/2, less than 1/3, x greater than 1/3 would be one way of showing it. Or you could actually go x greater than -1/2, where x cannot equal 1/3. Right? Because it's everything there except for that one value. Okay? So that would be another way of showing it. Or using your interval notation. What about if I had asked for, listen please, quietly, a lot of chatting. Right? So if I had asked for the opposite, so if I had said 2x plus 1, 3x minus 1 squared less than or equal to 0, okay, then that would be x less than or equal to -1/2. And would I be done? No, what did I miss? Exactly. Because of that equal sign, I need to include that one dot there. Basically, it's everything that I didn't have read, right? Because this is the opposite of this. So then you would say x equals 1/3. Right? It would be all of that. So just be aware, right? Does it have the equal sign? Is it touching the x-axis anywhere? Because it needs to include that point. Okay, so that's a different question, right? But I did a different color. Okay, so there you go.